Okay, to solve question 2 from the graphing calculator part of the practice test, we're going to use matrices, and there's several ways to do this, but what we're going to do is we're going to take this system and we're going to write it as an augmented matrix, and then we're going to use the row reduction. We're going to use the calculator to find the row reduced echelon form of this. I think that's the easiest. We could use inverses as well, but I'm going to show you how to find the reduced row echelon form of this and show you what that means. But like I said, the first thing that we have to do is we have to write this as an augmented matrix, and the first thing, or the first step in that process, is to make sure that our x's, y's, and z's in that order on the correct side of the equal sign equal to the constant. And when we do that, the first thing we would need to do here is this equation becomes 4x plus 2y minus 2z is equal to 4. And so now the augmented matrix is simply made up of the coefficients. Column 1 is x, column 2 is y, column 3 is z, and column 4 is the constant of the number, and then we have equation 1, 2, and 3. And it doesn't matter what order we do this. The graphing calculator is going to manipulate them to get this in the reduced row echelon form for us. So the first equation, first coefficient 4, second 2, negative 2, and 4. Second equation, 2, 8, 4, and 32. Third equation, 30, 12, negative 4, and 24. Once we have this, we go to the graphing calculator. And you can either do this before or after. I would do it before, especially if you're going to use your alpha function shortcuts here. So what I would do is I would go to second matrix, and I would go to math, and I would go down to option B. And option B says it's going to take whatever matrix we type in after this command, and it's going to put it in reduced row echelon form, and I'll show you what that means and how that's going to solve for x, y, and z for us. Okay. Now we're going to need to input the augmented matrix, and that augmented matrix is a 3 by 4. So using our shortcuts, alpha F3, 3 rows by 4 columns. Okay. Row 1 is 4, 2, negative 2, 4, 4, and didn't mean to hit enter. That's not the way to go about this. Okay, we're going to need to use our arrows when we hit enter. It's going to calculate that and have all our elements in. So going back, it's 4, 2, negative 2, 4, 2, 8, 4, and 32, and 30, 12, negative 4, and 24, 30, 12, negative 4, 24. Now that we have those in, when we hit enter, it gives us the row reduced row echelon form. Now, these decimals, we'd like to see if we can convert these to fractions, and this goes for any decimals that you have. If you hit math, option 1 is frac. We're going to turn those answers into fractions. And here's what we have. It took that augmented matrix and manipulated all the equations through multiplication, addition, division, add, addition, subtraction to get us this. This is a 3 by 3 identity matrix. Now keep in mind that this first column, okay, represents the x coefficients. Okay, if you look at this equation, we have a coefficient of 1 for the x term, so 1x or just x. This is y, this is z. We have 0y, 0z, so 1x is equal to negative 16 over 23. So that is the value of x. Now think about how we solve systems of 3 equations and 3 variables. We take a system of 3 equations and 3 variables, and through combinations of equations, we get that down to a system of 2 equations and 2 variables, and then we use combination, elimination, substitution, graphing to get that down to 1 equation and 1 variable. Okay, like x equals y equals, those are the values of the point of intersection. Well, in this case, it's the same thing. 1x is equal to a negative 16 over 23, 1y is equal to 90 over 23, and 1z is equal to 12 over 23. These values here would be the x, y, and z values of the ordered triple, which represent a point in 3 dimensions, okay, which is the intersection of the 3 planes intersected by the equations given in our original system. So these planes intersect at that one point. That one point is this particular ordered triple, and that's how you solve question 2 using the reduced row echelon form in your graphing calculator.